Hello there. We are trying something different with this chapter because I'm going to be out tomorrow, so bear with me. This is chapter 7 of our hazardous materials class. The chapter is called Hazard Assessment and Risk Evaluation. I'm going to show you the PowerPoint and some of the things we're going to be working with. Let me just share the screen with you. First thing I'd like to show you is how this is going to work. What you'll see here is a sort of like a worksheet where I will embed under Objective 1, I will embed the video that we're making right now, and we'll call it Part 1, and then you'll go through, you'll watch the video, you'll go through, and then you can answer all these questions with short answers. Okay, and then you submit it at the end, and we look at it to make sure to see if you got it or not. So there's 3 ways you can use this. You can go back to your book, use your book to try to figure out what this is. You can also look at the slideshow that we're going to start right now. Okay, the name of the chapter is Hazardous Assessment and Risk Evaluation. This is the 4th step after you've managed your site, ID'd your product, figured out, actually it's your 3rd site. You're going to, or selected your PPE, and then figure out how bad is this thing? How bad is this chemical we're dealing with? How bad is the situation? So we're going to describe, the learning objective is describe the concept of hazard and risk evaluation. So when we do that, we look at different, we make some critical decision points. We're out there gathering information. Once we have all that information, we start looking at the risks involved. What is it? Is it good, bad? It's all bad, really, but how bad is it? You are going to decide at the end, do we intervene or do we not? This is different than when, as a firefighter, when you are trained to do just about anything. This is a time where you have to sit back and think. As part of your training, we will go in and we'll isolate the area, deny entry, and then we'll attempt to identify the hazards. We went over that in the previous chapters. So now we're going to look at some critical benchmarks. We're going to look at hazardous assessment and risk evaluation. The process influences all differences in all disciplines in our community. We do this all the time. We pull up at a house fire, we assess the hazard, what's burning. We figure out, are we going to go in and make a rescue? Are we going to stand outside and squirt water and let the thing burn to the ground? So, what are risks and hazards? Now we can go back to your, we're going to go back to your assignment, and you're going to look at what are your risks and hazards, and using your book, you can look at flashpoints, toxicity levels, and exposure values. Okay, so let's see where we're at. Risks are intangibles. Okay, we know what they are, and we know that we can manage them. It depends on our level of training. It depends on the equipment we have on scene. It depends on the resources, and these are the factors that factor into that. So our level of risk includes nature of the material, what it is, what's the values, how is it contained, is it in a container, is it in a box, is it spread out all over the interstate, what stress does the container have, does it have a leak in it, is there fire, is there a nursing home or a trailer park near it, And like I said before, what do we have for resources? If you're out in the middle of nowhere, if you're out near Avaca or you're up in Pitcher Rocks, your resources are limited. So your decision-making process has to be weighed upon all these items coming in. So with that in mind, we gather that hazard assessment, we figure out all the bad stuff that's involved, then we go out and we make a risk evaluation, we develop a plan that's going to take care of our problem. Okay, we want to understand our enemy. What are we looking at? We want to understand our enemy. We want to identify and verify the materials involved and what hazards are out there. How will our enemy behave, meaning the chemical? How can it harm us? And what will it do to the environment? So these are some of the terms that we usually find what's coming up. There are also terms you need to understand, and we'll go through them one by one. Okay, when we talk about specific gravity, we've had this term before. We've had it in our some of our classes on fire behavior. Specific gravity is the weight of a liquid or solid as compared with the weight of water. Okay. If the specific gravity is less than 1, the material is lighter than water and will float. Can someone think of an example? That's right, gasoline, oil. If the specific gravity is greater than 1, the material will sink. Okay, most of your hydrocarbons are lighter than water, obviously, and they will float. So this is an issue we deal with. As how do we deal with it? How do we clean it up? How do we get rid of it? The next item is vapor density. Vapor density is just like specific gravity, only it deals with vapor or gas compared to the weight of air. Okay, the big question with vapor density is will it dissipate into the air or will it sink to the bottom? The common examples we give all the time are natural gas and propane. Boiling point. Boiling point is the temperature, and we all know this when water boils at 212 degrees, but boiling point is when a liquid turns to gas. Now, not all liquids boil at 212 degrees. A lot of them boil at a lot less, and some of them boil at a lot more. So that's important to know when you have a product on the ground. Is it going to evaporate in front of me and my problems will go away? Melting point is the same thing as boiling point, only it's when a solid turns to a liquid. Okay, this happens a lot, obviously, when we're talking about fire. If we heat an object and it starts to melt, we all know that when it starts to melt, it turns to a liquid, and when it turns to a liquid, it begins to give off vapor that can be easily ignitable. Next term is sublimation. Sublimation is a term we use when a product goes from a physical state. It's usually when it changes from a solid to a vapor without passing through the liquid phase. An example of this is dry ice and mothballs. An increase in temperature can increase the rate of sublimation. And the opposite of sublimation is deposition. That's when it goes from a vapor to a solid. So in the opposite. Vapor pressure is important to understand because it's the pressure that is exerted within a container to the sides of a container. Think of a bottle of water that's sealed and starts to boil. It starts to push against the sides of the vessel it's contained in. So these are some of the, and these are on your guide to go through. We're going to look at some other stuff right now. Just let me backtrack and let's go back and make sure we understand what we're going to be looking at. Okay. Know your enemy. Some of the other terms you're going to look at, what is a mixture? What is a solution? What is a cryogenic liquid? organic material, inorganic, and hydrocarbons. And then the physical properties you're going to look at is just what we just decided. You're going to go through there. Our next section is we're going to explain the following here. Okay, as we talk about the different chemical properties, we're going to talk a little bit about its toxic hazards, its flammability, how does it react, what is its corrosivity and radioactivity, and we'll also talk about biological weapons and agents. Dosage. The big thing with toxicity is how much do you get? How much of a dose are you going to get hit? Poison ivy is a toxic substance. A snake bite's a toxic substance. A bee sting can be a toxic substance based on the concentration and how long you're exposed to it. If you get stung by one bee, most people don't react to that unless they're highly allergic. However, if you're stung by a hive of bees, which is a heavy concentration, you are going to see some toxic hazards. And how your response to that is based on that. Flammability, we look at a bunch of factors here. Flash point. In flammability, the flash point is the minimum temperature at which a liquid gives off sufficient vapors that will ignite. Okay, we usually look at a non-sustainable combustion at this point. We pass a heat source by it. It may explode, it may flash, but it won't continue. The fire point is slightly higher. This is a point in which vapors are given off that will sustain combustibility. We stick a match to it, it starts lighting, and it keeps moving. Auto ignition is where it rises to a temperature where a product will, or a chemical will, auto ignite on its own. So if we have a tank car filled with certain flammable liquids and it's heated up to a certain range, it doesn't even need a spark. It will just explode or burst into flames. And then the toxicity or the toxic product of combustion, what kind of gases are given off when products burn. For example, when paper burns or wood burns, we get products of combustion of CO2, carbon dioxide, carbon monoxide, and little bits of carbon from our unburned product. Keep this in mind when other bad stuff burns. Other things we need to look at is how is the property going to react? Is a chemical going to react? Is it stable or unstable? Does it give off oxygen or does it need oxygen? Its oxygen ability is to give up its oxygen molecules to stimulate the oxidation of organic materials. Okay, so we have a product that's starting to give off oxygen, which readily combines with other stuff in the area. Okay, we'll skip over that. We'll move to the next, and we'll just keep moving through this. Okay, corrosiveness is its ability to eat away at a product, your skin, anything. Living tissue is subject very highly to corrosives, and we need to do that. We need to guard ourselves against that. We use pH strength to measure its strength and concentration. Radioactivity is the ability of a material to emit any form of radioactive energy. Some of the topics that we talk about today, and it's a result of our changing world, is the chemical and biological weapons that are out there. There are many out there. There are nerve agents that affect your nervous system. There are choking agents, blood agents that asphyxiate you. There are blister agents that irritate your skin. And there's also riot control, such as tear gas, that's called anti-personnel agents. It just makes it for a bad day. You've heard sometime in the news, you've heard about sarin gas and VX gas. Those are things that are nerve agents. They affect the nerve system. We also look at choking gases such as chlorine and phosgene. Some of the world, these have been around for a while. Mustard gas, tear gas has been around for a while. So these are the things that they hang around. That's what persistence means. It's the ability of a chemical to hang around and really do some damage to you. Okay, I think we're gonna stop here, and we're gonna go back, and you're gonna look at what you're gonna put in here, chemical agents, and I think that's where we stop. The next point we'll go on is we'll talk about how do you find these things when you're out in the field? How do we know when it's good or bad? Okay.